Hello and welcome to my channel. Today we're going to go over the very first problem on Leetcode, the two-sum problem. Let me pull it up here and we'll go over the directions real quick. What they are asking for is, given an array of integers, nums, and an integer target, return the indices of the two numbers that add up to the target. So we may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Oh, okay. Well, I did not know that because I've been trying to work on this and do some different kinds of methods, and I thought it had to be in that order. Oh, well. Okay, so for example 1, we have our nums 2, 7, 11, 15, target 9. The output is 0 and 1 because it's wanting you to return the indices of the two numbers that equal the target. And then for the hints, it tells you to probably think about using a hash map to speed it up. And so in this video, I did 3 different ways. I used Numpy. Actually, I imported NP to make it a little bit faster. And I implemented the Itertools combinations. And lastly, I did the hash map. So we're going to go over each of those different methods and see which one is the best. Which one do you think is the best? Let's code this together and have some fun, because this really was a fun problem for me, and I love solving these types of things. It's almost like a puzzle where you put the pieces together and see how it's going to run and see which one's the best. So let's get to it. We're going to start with the Numpy solution to our problem. I wrote down the directions, very similar to what I've done in past videos. It helps me to systematically go through the problem and keep me on track. And I need to stay on track many times because my mind is, it's all over the place. So let's have some fun with Numpy. Okay. There are many ways that we can tackle this problem, and I'm sure there are many you can think of, but let's do Numpy and then the combinations and then the actual fastest way, which is with a hash map. So let's see. I imported NP, which makes it easier to code and faster with just 2 letters. I brought over our nums and our target, and what I wanted to show you first was turning the nums into a matrix, because I thought it was pretty cool. I'll show you what I mean by this. We have to first turn our nums into a column like this. I'll name it column nums, if you will. And we just have to use the reshape, our nums, our len, I think this has to be in parentheses, len of nums, and then just 1, and then we can turn it into a matrix by just adding the column nums up to our nums. And we can see that by just printing the matrix. And you'll see that they get added together like this. And you can see that our target number is here. It's in this row, and then it's also in the next row. However, in this first row, the index position is actually 1. So if we actually just returned this, it's going to print out 1, 0. It's not going to give you the exact result, but it's just really cool to look at. I don't know. I was kind of excited about it. Okay, so let's just hashtag this out and move on to writing our function. And to do that, we need to define our two-sum. And since we're using NumPy, we need to turn it into an array like so. We're just going to call it nums array, and we do this just np array nums like so. And then we're going to iterate over our indices, not the array. And you'll see how this works out here. So it's for I, and you can use the np dot a range, no space in between, to do this, but it actually just creates another variable when you don't need to do that. This, you can just iterate right over the range of the nums. You don't have to really create an additional thing. Anyway, the range of our array, which our nums array, we're going to use the np where function and save it into a variable which I'm going to call results, but I'm gonna call it res for short. And what it does is it adds elements in the array to each other where they match the target. So we'll call it res equals np where nums array I plus nums array. This time it's going to be I plus 1 to the end of the array, where it equals target. And we need to put a 0 there because we're calling the first row. I'm sorry, not the first row, the first element in this array. So I wrote out here the 0 in the brackets at the end of the res variable is because we don't need all the data type information that gets included with the where function. Okay, and if we just print what this is doing in the where function, if we print that out without creating the equal target, we're taking out the condition and we're printing just what it's doing, it is adding them, it's adding the first two together, and then it's dropping off all the way down till it's decreasing all the way down till it's an empty array. So you can see here that our target is actually right here, the first element in this array. Let's see, and then if we print res, let's hashtag this out and print res. Now you're going to see that it's going to return 0 because that's our target in the 0 position, and then the target's not there and anymore, so it's returning empty arrays. Okay, so since we have our target met in our where function, all we need now is an if statement to return the array that isn't empty. So let's do this. If len of res is greater than 0, then we are going to, let's keep this in line here with our directions. Then what we need to do is return in brackets our index and then an integer, because it'll return the data type information. We want the actual integer, as you've seen previously when we printed that out, our integer of res plus I and plus 1, like so. And let's see what happens when we print. We get a 0, 1, which is our original 0 placement for 2 and 7. That's it. I know that maybe sounded really confusing, but it wasn't because there's so much directions in here. I'll span this down so that you can see this, and I'll take out all the directions. Hey there! If you made it this far and enjoy what you're seeing, why not subscribe? I upload fresh content all the time. Thanks for watching. Okay, let's move on to our next way of doing this. And when we're all done, I'm going to show you how expensive each one of these functions are. obviously, like I had mentioned, the HashMap is the least expensive. It uses the least amount of memory and it runs the fastest. This one, I can't remember. We'll go over it at the end. So let's move over to the next way of solving this using the Itertools combination. For our next way of solving this problem using Itertools combinations, we first want to import our modules from Itertools, import combinations. And in order to see this work, let's create some pairs first, and I'll show you how this works. So if we write pairs equals combinations for our nums 2, we do it like this, but it creates an object that we need to loop through. So for pair in pairs, we can print our pair, and to make it horizontal, let's just throw in an end here. There's nowhere near as much directions on this one, and I think this is really elegant. I really like this. Let's see, we need to no, why isn't this printing? Like so, it's printing all the combinations of 2 numbers throughout our nums. And if we print the sum of each pair, you'll see that we have our target right here. I really like the elegance of this method of solving the problem. I think it's really smart, and there's not a lot of directions. It's very simple. And so once we have those 2 things, all we need to do is just plug it into our function. So same thing, we're going to create our pairs. Actually, I'm just going to copy it. Let's just copy and paste. It's so much funner that way. And we're going to loop through our pairs again. And looks like this. Pair in pairs. And let's see. And then all we have to do is just put an if statement here. If sum pair equals target, what we need to do is just return and list comprehension. We would just return index or index value and enumerate. I get cheat here. Nums if val in pair. And then we just print our function. No! I did it again! Target. Those pesky little colons.
Bruh.
Okay, there it is. I keep forgetting that we should. Okay, let's. There it is. There's the solution. Let's see, 1, 2, 3, 4, 5 lines of code. But again, this isn't the most, I don't know how to say this. It isn't the least expensive way of solving the problem. It's just fun to figure out all the different ways we can do it. And I was really leaning towards the Numpy for solving it because I felt like there had to be something. It's pretty fast, but again, it's not the fastest. This one's not the fastest either. So let's move on to the fastest way to solve this problem. Our last solution is actually the recommendation for the Leetcode problem. I'm going to move this over a little bit here. It's the fastest and it is the least expensive, is using a hash map. So I'm not going to retype all of this out. It's very fast. There's not a lot of code here. What we are going to do is take this code and plug it into the visualizer. So that way you can see how this is running. I'm going to go over it here very briefly and then we'll move over to the visualizer. First thing we want to do is create an empty dictionary, and then we're going to create a for loop that's going to go through the indices and the number in our enumerated nums list. We create a variable m, which takes our target of n and subtracts our first indice, which is 2, and then m becomes 7. And what it does is it asks if m is in the dictionary, and since 7 is not in there, it's going to put it in there. It's going to put it in as, it's going to put the 2 in as the key and 0, the indice, as the value, and then it's going to loop through again, and then m becomes, our target becomes 9 minus 7, which is the next number in the element. And so 9 minus 7 is 2. It goes down if m is in the dictionary, which 2 is, and then all it does is return the indices of 0 and 1. So to see this in action, let's go over to the visualizer and check it out. Let's see here. I copied and pasted the code right into here. Let's run it and I'll show you how it goes through. The first few are going through the globals, print, creates the dictionary. It's gonna go through the for loop. M is the target, 9 minus 2, which becomes 7. If 7, it's not, oops, I hit the right key. It's going to put it in the empty dictionary. Like I said, 2 becomes the key, the indice becomes the value. It's going to go through again. It's going to take the 7, subtract it from the target. It becomes 2. Is 2 in the dictionary? It is. And now all it does is just return the 0 and the 1. It's going to return the indices of our first 2 numbers in our list. So what I did was I went into Leetcode and I did all the solutions for the Numpy, for the Itertools collection. I'm sorry, I keep calling it collections. It's combinations. I'm gonna have to pause this because the garbage man is here and my dog is going to go nuts.
A few minutes later.
As you can see on here, the fastest, the best was the hash map right here, the accepted one. It had the fastest runtime and it used the least amount of memory. Up here, this one was the Numpy. It's twice as much memory. I don't know, 3 times as much runtime. The combinations one was the worst for the runtime. The memory wasn't too bad, but that's it. The HashMap one is the best. So when they recommend it, we should probably do it. Anyway, I hope you learned something here in this video. I had a lot of fun figuring out which one was the best. I had my heart set on Numpy, and I don't know why, but in my head, when I see that word, I think Numpy, and I had to fight to not say Numpy. I hope I didn't. Maybe I did. Hopefully I didn't, because I'd look like a complete idiot. But anyway, that's the way I see it. So my heart was towards the Numpy. I knew there was something in there that could solve this problem. It wasn't the best, but I had a lot of fun trying to figure it out. And I knew there was one for combinations as well. And, you know, it's always a learning process to look at this problem and go, what are some ways I can solve this? And then figuring that out. And it's a journey for every problem. And this one, like I said, was a lot of fun. Anyway, if you have any suggestions for another video, feel free to comment down below. The link to this problem will also be in the description box. And that's it. So until next time, happy coding. Bye-bye.